Hello. The first thing I want to point out is that I am super annoyed. I did not capitalize atomic mass. That looks so sloppy. Just ignore that error on my end. All right, so this section is involved with isotopes and atomic mass. And so we have currently been learning about the atomic theory and how the atom came to be. And so we've done a whole bunch of history. You've made a timeline for me. And now we are going to go into the nitty gritty of atoms. So we're going into the very basic stuff when it comes to atoms, how to distinguish an atom on the periodic table, and what are some distinguishing features between the two. Or excuse me, not between the two, but between different types of atoms. So after you watch this video, you should be able to define atomic mass, define mass number, understand how isotopes differ from one another, and be able to designate them by various methods. And you should be able to calculate the average atomic mass of an element. Do not worry, I'm going to show you how to do all this. Some quick things to remember before we even progress through the information is, remember, we had scientists that have already discovered that the atom is not just a hollow ball, it's made up of a nucleus. Inside of the nucleus, we have protons and neutrons. Outside of the nucleus, we have electrons circling around. So three fundamental subatomic particles are the electron, the proton, and the neutron. Those make up your atom. Remember that Thomson discovered the electron, Rutherford discovered the nucleus, and within the rest of the time frame, the protons and neutrons were also discovered. Sorry, I'm just trying to make sure I don't take up too much of your time. All right, so some information that you should know about an atom. The idea of the atomic number. Anytime we're talking about an atomic number, you should, and if you see it referred to as the capital letter Z, we are talking about the atomic number. So the atomic number of an element is the number of protons in the nucleus of each atom of that element. So that means that your atomic number equals your number of protons. Your atomic number never changes. So that means your proton number never changes. It's a distinguishing feature of an element. So an atom can be classified as a particular element based solely on its atomic number. So for example, any atom with an atomic number of 8, its nucleus contains 8 protons, is an oxygen atom. Okay? The things I want you to know is that electron number and neutron number can change. Proton number can never change. Write that down. Protons never change. It's really hard to write with my finger, sorry. All right, so proton number never changes. Electrons and neutrons can change. But the proton number and the atomic number are two things that distinguish what type of atom you are looking at. So the periodic table displays all of the known elements, and they are arranged in order of increasing atomic number. We have 1 for hydrogen, and for like number 203, we have Lr, which I can't even read that name right now. But the atomic number is equal to the proton number. And when you read the periodic table, it's in sequential order based off increasing atomic number. So that means that if you were to go over to helium, which is He, this has an atomic number of 2. That means it has 2 protons. Lithium atoms have 3 protons, which means they have an atomic number of 3, and so on and so forth. So since atoms are neutral, the number of electrons in an atom is equal to the number of protons. So anytime we're talking about an atom, always assume it's neutral unless I tell you otherwise. Okay, like I said, your electron number and your neutron number can change, but that does not mean they're neutral anymore. A neutral atom means that the proton number equals atomic number, which equals the electrons. If you want, you can think of this acronym as APE. So atomic number equals proton number, which equals electron number. That is in neutron atoms only. There was something else I was going to add, but I can't remember, so hopefully I'll remember in class. We next have what's known as a mass number. So remember in Rutherford's experiment, he showed that the vast majority of the mass of an atom is concentrated in its center, and he names that center the nucleus. Okay, so not these discoveries and this timeline that I had you made, it's not just so you know the history of the atom, it's because we're going to take these ideas and then make them bigger. So again, the vast majority, the primary mass of the atom is concentrated in its center in the nucleus. So the nucleus is made up of protons and neutrons. The mass number is defined as the total number of protons and neutrons in an atom. So how you determine mass number is you add the protons and the neutrons. Remember, we can get proton number from the atomic number. So if I were to ask you how many protons does beryllium have, and I gave you the atomic number of 4, you should say 4 protons. Now, in order to find the mass number, you would also need to know the neutron number. I would never expect you to memorize neutron number. It would be something that's probably a little bit difficult to just know. More specifically, I can give you, like if you're looking at a periodic table, you can infer the mass number from there. So I'm going to give you an example as helium. So its atomic number is 2, so it has 2 protons in its nucleus. Its nucleus also contains 2 neutrons. That's information that I have to give you. So we can determine the mass number by adding the atomic number plus the neutrons. So 2 plus 2, the mass number of helium is 4. Okay, and you can manipulate this equation. So I've given you another acronym known as MAN. So mass number equals atomic number plus neutrons. So the 2 acronyms you should know at this point are 8-MAN. And remember, APE means their atomic number equals proton number, which equals electron number. MAN means mass number equals atomic number plus neutrons. You can manipulate that equation. So if I gave you the mass number and the atomic number, you could determine the number of neutrons by just changing the equation around. And we will practice this in class. I have a way that we write atomic structure using subscripts, and I will show you that in class. But if you want an example now, I can also show you now. So here's chromium, and 52 at the top, 24 at the bottom. These are ways we represent a neutral element of chromium. It's a shorthand notation using the atomic number and the mass number. So both are written before the chemical symbol. So you see I have the 2 numbers here. They're written before the chemical symbol. The mass number is written as a superscript, and the atomic number is written as a subscript. Okay, so superscript is at the top. The subscript is at the bottom. So I'll state it again. Your mass number is at the top. Your atomic number is at the bottom. So this is telling me that chromium has a mass number of 52, an atomic number of 24. So you can determine the number of neutrons by subtracting 24 from 52. Another way you'll see that atoms are typically written is you'll see that there'll be the full name. So we'll say chromium is the full name. And then dash 24. This indicates that you are talking about the atomic number 24, which is chromium. And so that's just another way to write that. We will practice that in class, and you will be expected to know that for an upcoming quiz. Isotopes. And so this is where I'm going to start talking about how our subatomic particle numbers can change. The one thing I want you to remember, and always, always, always remember, proton number never changes. Proton number is the atomic number. That can never change. Okay, proton number never changes. So, like I stated earlier, not all atoms of a given element are identical. So I did say that electron number and neutron number can change, and that makes them different than their neutral brother or sister. So, like I said, specifically the number of neutrons in the nucleus can vary from elements. So now I'm talking about a form of atoms that changes based off the neutron number. So isotopes are atoms that have the same atomic number but different mass numbers due to a change in the number of neutrons. Remember, to determine the mass number, you're adding your protons, which never change, plus your neutrons. If your neutron number changes, you are now known as an isotope. Carbon has 3 forms of itself. So it has a different mass number just based off the number of neutrons found in the atom. The three isotopes of carbon can be referred to as carbon-12, carbon-13, and carbon-14. Naturally occurring samples of most elements are mixed of isotopes. So carbon has only 3, but some have many, many, many more different types. So for example, tin has 10 stable isotopes, which can sustain. As far as when we go into these details, you will need to be able to identify whether I'm giving you an isotope or a neutral element. So I can give you, remember, I'll give you like the shorthand expression. So let's say I give you phosphorus 31 over 15. Remember again that your atomic number is at the bottom, your mass number is at the top. So to determine the number of neutrons, you would 31 minus 15, which gives you 16 total neutrons. If we go and look up phosphorus on the periodic table, that's number 31. I can't read the mass number, so that's not helpful. But I can tell you that that may or may not be a neutral element. At this point, right now, you should always assume your electron number equals your proton number. When we start talking about the activity of electrons, we'll start talking about a concept known as ions. And ions have different roles and they have different number of electrons. But right now, you should always assume your electron number equals your proton number. The only thing we've talked about changing is your neutron number. And finally, we have what's known as atomic mass. And atomic mass can be a little bit confusing. We have already talked about a mass number, but atomic mass is a bit different in the fact that it's the mass of individual atoms, and they are obviously very, very small. You can use modern devices to figure out a very debatable measure or mass, but it is generally accepted. So an atom of oxygen, so oxygen 16, for example, has a mass of 2.66 times 10 to the 23rd grams. Super freaking tiny. Okay? So, when you're comparing these to different atoms, you should know that there are atoms that are considered heavier than others, but scientists have decided to use carbon-12 as the reference standard by which all other masses would be compared. So by definition, one atom of carbon-12 is assigned a mass of exactly 12 atomic mass units. Atomic mass unit is different than a mass number. An atomic mass unit is defined as a mass equal to 1/12 the mass of an atom of carbon-12. The mass of any isotope of any element is expressed in relation to the carbon-12 standard. I know that sounds really confusing. When I talk about mass number and atomic mass unit, they will maybe look like they coincide, but I'll distinguish those better in class. We will do a Venn diagram, and we will figure out how to calculate your atomic mass in class. I didn't want to do that on this video because I felt like it would be really confusing. So again, we will do that in class. If you have any questions, please, please, please ask me on Edpuzzle.